Hello, and welcome to this edition of Short Video Series where we showcase Bluecoat SSL Visibility Solution in action. During this short video, we would like to show you how Bluecoat's SSL Visibility appliance allows you to eliminate your encrypted traffic blind spots in the network. During this demonstration, we will utilize most popular open source network intrusion detection system called Snort. The test is very simple. First, we will, without decrypting the traffic through SSLV, we'll go to a known bad place on the internet and we will download a known bad file. Now, normally, if Snort sees that file in plain text and open, it will raise an alert. But we'll see what happens when SSLV is not decrypting the traffic and SSLV is decrypting the traffic. Now, this video focuses on how SSLV enables Snort as a network intrusion detection system with the full visibility into SSL traffic. If you're interested in learning how SSL Visibility Appliance can help with other security solutions, we welcome you to watch our other videos in this series. Now, let's look at the SSL Visibility Appliance to ensure that it's not decrypting the traffic before we start our first test. This is the user interface for SSL Visibility Appliance when it comes to defining the rules and policies on what traffic will be decrypted versus what will be cut through or bypassed. If you look at the traffic rules, the first rule calls for an action that says cut through, which essentially means that when SSL Visibility Appliance sees the traffic on its network interfaces, it will simply bypass them and will not attempt to decrypt the traffic. To learn more about SSL Visibility Appliance's interface, policy, engine, and other configuration options, please watch our other videos in this series, one in particular called SSLV User Interface Overview. Now, before we start the test, let's go to the SSL session log and we'll mark it running so that when we run our traffic, we can come back here and see what SSL Visibility Appliance has been up to. So now we are ready to run our first test. And before I go into running the test, let's look at the current status of Snort dashboard. I'm using Snorby as the front end to look at the alerts. There are other options too. But if you look at the dashboard here, at this moment, Snort is telling me that I've known of 6 high severity alerts, 7 medium, and 7 low severity alerts. Before we go further, let's look at when was this last alert was reported. It was 2:19 in the morning. It was a UTC time. So we'll keep this in our memory because when we come back here, we want to see if the report, if the alert was generated, when was it generated, and what action provoked it. So let's go to our test client. I'll keep this in perspective. Let's go to our test client. Open my Mozilla test browser, and using HTTPS. Visit this known site, known bad site, and download a known bad file. When we hit OK, it prompts me to download this file. And I'll simply save that file. And I'll go back to my SSL Visibility Appliance's SSL session log. So remember, we configured the box not to intercept any traffic. So at this moment, we see there's a log line saying that on this segment, traffic coming from our client, which is 77, going to this domain where was serving a self-signed certificate, which in itself is a bad news. Using the following cipher suite was cut through. It means we did not intercept the traffic and we did not decrypt the traffic. Let's see if Snorby or Snort is reporting any changes, any alerts. So let's refresh this and go back to dashboard. Remember, the last alert was reported at 2:19 UTC time. And so nothing changed here because we know that Snort by itself is not capable of looking into SSL traffic unless you give it the SSL traffic in a decrypted form. which is essentially true for any other security device, be it an IDS, IPS, or a malware inspection, malware detection system in a network. If they do not have visibility into SSL tunnels, SSL traffic, they will not be able to inspect it and raise the alerts when they see something bad happening, right? So in the next test, we will go to our SSL visibility appliance and configure the rules a little differently. And this time I'll go to rule sets, and instead of cutting through all the traffic, I'll simply move this little rule that says cut through everything all the way to the bottom. So now with this configuration, we are decrypting the traffic, except if it is the remote desktop, that port you see here, because I don't have the certificate for that for this demo. But employees' personal information, personal banking, health, and broker trading, those categories, those sites are not decrypted. Personal information, don't want to look into it, but everything else I am decrypting at this moment, right? So I hit apply. That's what it takes to change a policy. Now we go into monitor mode again, start the SSL session log, and mark it running. In this test, we will continue to monitor what SSL Visibility Appliance has been doing, but let's ensure again that our policy is set to cut through, but decrypt everything else. So we'll go now to Snorby dashboard, refresh it yet one more time to ensure that we are still at the same count. And I'll go to my remote client now and open the same browser and go to same place. And see what happens. So I didn't see any warnings because I trust SSLV's certificate in this configuration. I'll simply save this file. Go to my SSL Visibility Appliance first and see the SSL session log status and see what happened here. So in this case, since we are intercepting and analyzing or decrypting the traffic on SSLV, we see that same client going to same domain using the same certificate and cipher suite, the action was decrypt, and we were able to successfully decrypt that traffic, which means that what we served to Snort, monitoring port, was actual decrypted traffic. Let's see if Snort was able to identify a bad file, and it'll raise the alert. So here I am refreshing the dashboard, and here is that alert. So let's look at when was that alert raised. So remember, we saw the last alert was raised at 2:19 UTC. This is the new one. Now let's look into this alert with a little bit more details and see why this alert was raised in the first place. This shows me the data on that virus.exe, that one particular file that we downloaded, and that was the reason why Snort alert raised the alert. Now, like I said before, this is exactly how other security identification or prevention mechanisms work on your network. They capture the data either in active mode or in passive mode, raise the alert, or identify if something is wrong with that traffic. So folks, this is where we started, and we looked at a use case where we used SSL Visibility Appliance, which was serving the decrypted traffic, which was transparent to the user, to Snort. And at that time, Snort was able to utilize its engines to detect anomalies on the network or the bad traffic and raise an alert, which it's supposed to do. And we all know that the encrypted traffic in the networks are increasing, and SSLV at this point becomes very important for network intrusion prevention systems and network intrusion detection systems, in addition to the DLP devices. Now, there's another thing that I want to tell you while I have your attention is Blue Coat SSLV device can take the traffic, decrypt it once, and serve it to multiple security devices in your network without having to decrypt multiple places. That's another thing about SSLV. I hope you enjoyed this little video.